Welcome to Elevate Learn. Today we're diving deep into one of JavaScript's most powerful yet often misunderstood features, generators and iterators. These tools let you write cleaner, more efficient code by giving you fine-grained control over how data flows through your application. Whether you're working with large datasets, implementing lazy evaluation, or building complex async workflows, understanding generators and iterators will level up your JavaScript game. Let's get started. Here's the roadmap for our journey today. We'll start by understanding the iterator protocol, the rules that define how iteration works in JavaScript. Then we'll explore how to create custom iterators manually, before stepping into the world of generator functions which make creating iterators incredibly simple. You'll learn how the yield keyword pauses and resumes function execution, giving you unprecedented control. We'll look at real-world applications where generators shine, discuss common mistakes to avoid, and why generators are so efficient with memory. By the end, you'll have a solid understanding and we'll test your knowledge with some interactive quizzes. Let's establish the foundation. In JavaScript, an iterator is simply an object with a special next method. Every time you call next, you get back an object with two properties. Value, which is the current item, and done, a boolean telling you if there are more items. An iterable is something that implements the symbol.iterator protocol. It has a method that returns an iterator. This distinction might seem abstract, but it's crucial. When you use a for of loop or the spread operator, JavaScript is calling these methods under the hood. Understanding this protocol helps you create powerful custom iteration patterns and appreciate why generators are so elegant. Now meet generators, functions with superpowers. A generator function is declared with an asterisk after the function keyword. What makes them special is the yield keyword. When execution hits yield, the function pauses and returns a value. Call next, again, and it resumes right where it left off. This pause and resume capability is incredible. You can create functions that generate values on demand, which saves memory and CPU cycles. Unlike regular functions that execute completely from top to bottom, generators give you fine-grained control. They're also iterables, meaning you can use them with for of loops and other iteration tools. This opens up possibilities for lazy evaluation, infinite sequences, and elegant async patterns. The yield keyword is the heart of every generator. When a generator hits yield, it's like hitting a pause button. The function freezes its state, returns the yielded value, and waits for the next call. Here's the elegant part. When you call next, again, execution resumes right after that yield statement, with all local variables intact. Even more powerful, yield is bidirectional. The caller can send values back to the generator via next value, allowing two-way communication. You can also use return to end the generator early, or yield asterisk to delegate to another iterable. This combination makes generators incredibly flexible for everything from data pipelines to state machines. Here's the verbose way to build an iterator. We create an object that implements symbol.iterator, returning an iterator object with a next method. The next method tracks state using a closure variable and returns the appropriate value, done, object. While this works perfectly, you can see it's quite verbose for something simple. This is exactly why generators were invented. They handle all this boilerplate for you. Notice how we're using for of on our custom iterator. That's the symbol.iterator protocol in action. This example teaches you what's happening under the hood in every iterable you use. The output shows our custom iterator working perfectly. We see 1, 2, and 3 printed in sequence. Here's what happened behind the scenes for of called symbol.iterator on our object getting the iterator. Then it repeatedly called next, each time logging the value until done became true. The beauty here is that the internal state, our current variable, persists across next calls. This is closure in action. The iterator pattern lets you generate values on demand rather than all at once. Imagine iterating over millions of records. With this pattern, you'd only load what you need. Now here's the generator version of the same logic. Dramatically simpler. The function asterisk syntax tells JavaScript this is a generator. Inside, we use yield to return values and pause. The generator function automatically implements symbol.iterator and returns a proper generator object. No manual state tracking, no boilerplate. Each next call resumes execution at the yield, increments current, and yields the next value. When the while loop ends, the generator automatically returns done, true. This is the elegance of generators. Compare this to the previous iterator. Same functionality, but far less code and infinitely more readable. Perfect. The output clearly shows the generator protocol. Each call to next returns an object with value and done properties. Notice the pattern as we iterate through 1, 2, 3, done remains false. Only when we exhaust all yields does done become true. The final call returns undefined as the value because there's nothing left to yield. This lazy evaluation is crucial. The generator only computes values when you ask for them via next. If you had 1,000,000 values to iterate, a generator wouldn't create all of them up front. Creates them one at a time as needed. This efficiency is why generators are perfect for large datasets or infinite sequences. Here's where generators get really interesting. You can send values back to a generator using next value. The value passed to next becomes the result of the yield expression. In this example, we yield a question, then receive the caller's response via next. This creates a conversation between the generator and its caller. First next, call starts the generator and pauses at the first yield. Second next, Alice sends Alice back, which becomes the name variable. Third next, 25 sends 25 as the age. This two-way communication pattern enables interactive generators, state machines, and even async workflows. The for of loop version still works but receives undefined from yields since for of doesn't send values back. Look at this output, it shows the power of two-way communication. The first 3 lines show direct next, calls with values being passed. What is your name? Is yielded first. Then we send Alice, which becomes the name variable, and the generator yields the greeting. We send 25 as age, and the generator returns its completion message. The last 3 lines show the same generator using for of, which only outputs the yielded values. This pattern is incredibly powerful for building interactive applications, game engines, or any system needing back-and-forth communication with async operations. Here's a real-world example. Generating Fibonacci numbers infinitely. The generator has an infinite while loop, but thanks to yield, it never creates all numbers up front. Instead, each call to next computes the next Fibonacci number on demand. We iterate until we have 8 numbers, then break. The generator never wastes memory or CPU computing numbers 9, 10, etc. This pattern is used everywhere, reading large files line by line, processing data streams, generating IDs, creating mathematical sequences. With a traditional function returning an array, you'd either limit the size up front or compute everything at once. This example shows composable generators creating a data processing pipeline. We have a numbers generator that yields integers, a filter generator that yields only even numbers, and a map generator that doubles each value. We chain them together. Numbers generates 1 to 10, filter keeps only evens, 2, 4, 6, 8, 10, and map doubles them to 4, 8, 12, 16, 20. The beautiful part is laziness. Nothing is computed until we spread the pipeline into an array. If you had millions of numbers and complex transformations, each generator would process only what's needed. This functional composition pattern is elegant and powerful. You can build sophisticated data processing pipelines by combining small, focused generators, each responsible for one job. Let me highlight the key differences between common mistakes and best practices. First, returning a huge array versus using generators. If you need millions of items, the array approach precomputes everything, crushing memory and making the function slow to start. Generators yield items one by one, instant startup, minimal memory. Second, manual iterator implementations versus generators. Yes, both work, but generators eliminate pages of boilerplate while being more readable. Third, blocking operations in loops versus generators with async patterns. If you're processing large files or network requests, Blocking loops freeze the UI. Generators with async patterns keep your application responsive. The pattern is clear. When you need to iterate, produce, or transform sequences of data, generators are usually the superior choice. Great question to test your understanding. The yield keyword is fundamental to generators. When a generator hits yield, it's like pressing pause. The function freezes its state and returns the value to the caller. The generator's local variables and execution position are preserved. When the caller invokes next, again, the generator resumes right after that yield statement. This pause and resume capability is what makes generators unique. Additionally, yield is bidirectional. The caller can send values back via next value, which become the result of the yield expression. This enables two-way communication and is foundational for patterns like coroutines and interactive applications. Excellent question that highlights a core strength of generators. Arrays require you to compute and store every single value in memory before you can access them. If you're generating 1 million numbers, that's 1 million objects in RAM. Generators, conversely, compute values only when requested. Iteration asks for the next value via next. The generator computes it, yields it, and pauses. Only the current value takes memory. For infinite sequences like Fibonacci, this is essential. You can't precompute infinity. This lazy evaluation pattern makes generators ideal for working with large files, API streams, or any scenario where computing all values upfront is impractical or impossible. Perfect question to solidify your grasp of the iterator protocol. An iterable is something you can iterate over. It implements the symbol.iterator protocol. When you call symbol.iterator on an iterable, you get back an iterator. The iterator is the actual mechanism that traverses values. It has a next method that returns objects with value and done properties. Think of it this way. An array is iterable, but it's not an iterator. When you iterate over an array, JavaScript calls symbol.iterator to get an iterator, then repeatedly calls next on that iterator. Generators are special. A generator function returns a generator object that's both iterable and an iterator simultaneously. Understanding this distinction helps you grasp how of loops work under the hood and how to design custom iteration patterns. You've leveled up your JavaScript skills. Here's what you've mastered today. The iterator protocol, a foundational pattern with next methods and symbol.iterator. Generator functions with the elegant function asterisk syntax, where yield pauses and resumes execution. Lazy evaluation, the game changer for memory efficiency when working with large or infinite datasets. Two-way communication that enables interactive patterns and advanced async workflows. Composable pipelines using generators, creating sophisticated data transformations from simple building blocks. You understand how of loops work under the hood and can now design custom iteration patterns. Most importantly, you recognize when and where generators shine: infinite sequences, processing massive files, building responsive applications. Generators aren't just a feature. They're a paradigm shift in how you think about iteration and data flow. Practice building generators, compose them into pipelines, and watch your code become cleaner and more efficient. Thanks for learning with Elevate Learn.